Good morning. So today we will start the concepts of interrupts in 8051. So 2 hours are allotted in syllabus for interrupts. Basically, we'll discuss about the different types of interrupts, then different interrupt sources, and how to handle those interrupts, then assembly language programming examples of interrupts. So this is a very important topic. So today we will start about the concepts of interrupt and different types of interrupt and its vector table. And in next class, we will do the assembly language programming for 8051 interrupts. So these are the objectives of today's lectures. We will compare interrupt and polling. Then we will discuss about interrupt service routine. Then we will discuss about the 6 interrupts in 8051. Then about the purpose of interrupt vector table. Then enable and disable of interrupts. Then programming we will discuss in the next class. And external hardware interrupt. Then different edge triggered and level triggered interrupts. Then 8051 serial communication interrupt programming. Then interrupt priority. These are the different topics in the syllabus regarding interrupts. And this is very important because for university examination, maybe they will ask 20 marks question from interrupt portion. I already shared with you the previous year question paper, so you can refer that. Then you will get to know about the questions regarding interrupts. So we started 8051 with the architecture. So we know what is CPU. Also, we played with oscillator and machine cycle, and we know what is bus, address, and data bus and all. Then we already know what is on-chip ROM. We already done different programs in ROM, and also we did different data-related programs using on-chip RAM. Then we know what is input-output ports. We've done different programs using input-output port. We created waveforms also using I/O ports. Then we did program using timer 0 and timer 1 for creating delay and for the counting operation. So these many portions in the architecture we completed. Now we need to complete interrupt portion and serial communication port. These two sections are remaining in this hardware. So this is a pin diagram. It's a 40-pin IC 8051. So these are the pins basically for interrupt. P3.0, P3.1 is a serial communication, not interrupt. P3.2 and P3.3 external interrupt pin, then timer interrupt pin. Here, all these pins, there is an internal hardware. But with the help of that internal hardware, we can use this as for interrupt operation. Then interrupt. An interrupt is an occurrence of a condition or an event that causes a temporary suspension of a program while the event is serviced by another program. So basically, just observe this. Usually, we will write a program like this. In our kill software, when you write a program, we will define the initial location, then we will do the program, then we will end the program. So this is a main program. So when you observe this main program, you will understand that when you are doing this program, simultaneously you cannot do any other programs. There is no other subdivision programs. It's a single line, it's a single program, this one. So it is doing a single task. But sometimes we need to do different operation at the same time. So we need to divide the CPU operation for different tasks. So for that requirement, we are using interrupt. So whenever we are using interrupts, main program will run like this, and along with the main program, we will run another interrupt programs. So interrupt programs locations is known as interrupt service routine. So in this interrupt service routine, there will be another program And this task is this will run whenever we call the interrupt during the main program. So main program and interrupt service routine, this both will run together, and the end user will think that CPU doing the task simultaneously. Basically, it is dividing the time spaces for main program and service routine like this, but external world will think like that it is doing all the actions simultaneously. So this is the basic concept of interrupt. This is without interrupt and this is with interrupt. When you look this, we will understand that for this one main program will take less time. For this one main program will take more time. But that time division we are using for another tasks. So we are dividing the CPU operation for different tasks using interrupts. Another method is there called polling. So maybe university, if they ask the difference between interrupt and polling, you just tell that interrupt, the device notifies the CPU that it needs a service, whereas in polling, CPU repeatedly checks whether the device needs a service. So the two opposite cases are interrupts. നമുക്ക് ഹാർഡ്വെയർ ഇൻട്രപ്റ്റ്സ് ഉണ്ടാവും. അപ്പോൾ ആ ഇൻട്രപ്റ്റ് ഹാർഡ്വെയർ ആണ് CPU പറയുന്നത്, നിങ്ങളുടെ കറണ്ട് ആയിട്ടുള്ള എക്സിക്യൂഷൻ സ്റ്റോപ്പ് ചെയ്യണം, ഐ നീഡ് ടു റൺ അനദർ പ്രോഗ്രാം. ബട്ട് ഇൻ ദ കേസ് ഓഫ് പോളിംഗ്, CPU ആണ് ചെക്ക് ചെയ്യുന്നത് ഏതൊക്കെ ഡിവൈസിനാണ് അതിന്റെ സർവീസ് ആവശ്യമുള്ളത്. So that is a core difference. An interrupt usually is a hardware mechanism, as CPU has a wire interrupt request line which signal that interrupt has occurred. On the other hand, polling is a protocol that keeps checking the control bits to notify whether the device has something to execute. So protocol ennu parana pedikirudhu, it's a simple word. Protocol basically a set of rules aanu, adu namukku software aayittu define cheyan pattum. So it's a software kind of thing. Interrupt usually is a hardware mechanism. So we will have a hardware inside the microcontroller for interrupts, and polling is just a software protocol. We can use different protocols in the software to control the operations. Then there are other differences also. You can read this. The core difference is that interrupt is hardware mechanism, and in this hardware, device will notify the CPU that it needs the service. But in polling, CPU repeatedly checks with the help of a protocol. And ISR, interrupt service routine. For every interrupt, there is a fixed location in the memory that holds the address of the interrupt service routine. So for usually in our system, 8051 microcontroller, there is the ROM memory. In that ROM memory, we allocated a certain memory locations for each interrupts. So that is interrupt service routine. And these are the steps in executing the interrupts. What are the steps? Microcontroller, whenever there is an interrupt request, microcontroller finishes the instruction it is executing and saves the address of the next instructions, which will be in the program counter, that it will save into the stack memory. Okay. Then it saves the current status of the all interrupts internally. It jumps to a fixed location in a memory called interrupt vector table. The microcontroller gets the address of the ISR from the interrupt vector table and jumps it to it and start the execution of ISR until it reaches the last instruction, RATI, return from interrupt. So whenever there is an instruction called RATI, the CPU will understand that ISR is completed. We can go back to the previous operation. So whenever there is an RATI, the microcontroller returns to the place where it was interrupted, and it gets the PC address from the stack by popping the top 2 bytes of the stack into the PC, and then start to execute from that address. So this is the step. എന്താണ് സ്റ്റെപ്പ് എന്ന് ഒന്നുകൂടി പറയാം. മൈക്രോ കൺട്രോളർ ഒരു മെയിൻ പ്രോഗ്രാം ചെയ്തുകൊണ്ടിരിക്കുകയാണ്. മെയിൻ പ്രോഗ്രാം ചെയ്യുമ്പോൾ നമുക്ക് ഇന്ററപ്റ്റിന്റെ റിക്വസ്റ്റ് കിട്ടി. അപ്പൊ ഇന്ററപ്റ്റ് കിട്ടിക്കഴിഞ്ഞാൽ CPU എക്സിക്യൂഷൻ ആ കറണ്ട് പ്രോഗ്രാം എക്സിക്യൂട്ട് കഴിഞ്ഞാൽ പിന്നെ സ്റ്റോപ്പ് ചെയ്യും. സ്റ്റോപ്പ് ചെയ്തിട്ട് നെക്സ്റ്റ് എക്സിക്യൂട്ട് ചെയ്യാനുള്ള ഇൻസ്ട്രക്ഷൻ, മെയിൻ പ്രോഗ്രാമിന്റെ ഇൻസ്ട്രക്ഷന്റെ ലൊക്കേഷൻ സ്റ്റാക്കിലേക്ക് ലോഡ് ചെയ്യും. അഡ്രസ് ഓഫ് ദ നെക്സ്റ്റ് ഇൻസ്ട്രക്ഷൻ സ്റ്റാക്കിലേക്ക് ലോഡ് ചെയ്യും. അപ്പൊ അതവിടെ കിടക്കുന്നുണ്ട്. പിന്നെ കറണ്ട് സ്റ്റാറ്റസ് എല്ലാം സേവ് ചെയ്യും. then it will jump to the interrupt service routine. Vector table vadi interrupt service routine like jump cheyum. Interrupt service routine le endana program cheyidirikkuna aa program pinna CPU execute cheyum until RETA. When it get RETA, it will come back to the main program and it will get the address of the next instruction from the stack, and that stack value will load to the program counter. Then from that program counter, it will a program counter actually pointing to the next location where the instruction is there for the main program. That main program instruction it will catch and it will run that instruction or execute that instruction. This is the steps in interrupt. എന്തെങ്കിലും ചെറിയ ഐഡിയ കിട്ടിയോ? ഇന്ററപ്റ്റ് സർവീസ് റൂട്ടീൻ അല്ലെങ്കിൽ ഇന്ററപ്റ്റ് എങ്ങനെ വർക്ക് ചെയ്യുന്നുള്ള ഐഡിയ എന്തെങ്കിലും കിട്ടിയോ? ഒന്നുകൂടി പറയാം. So this is a main program. Main program it's going like this, like this, like this until it reaches there. ഈ ഒരു ഇൻസ്റ്റന്റിൽ it is getting interrupt request. At that time, what happens? The CPU stop the execution and next address executing instruction address will be there in the program counter. That program counter value it will save into the stack pointer and all the other status internally. Save it will run to the interrupt service routine. Then CPU execute this instruction. After execution of this instruction, how the CPU will understand the last line of this instruction? The last line will be RETI. Whenever CPU get RETI instruction, it will stop ISR instruction. Then it will come back to the main program. So already next instruction is saved in the stack. It will copy that value from the stack to program counter. With the help of program counter, it will take the instruction from memory and it will run the main program again until it will get another interrupt. So this is the step. ഇവിടെ തന്നെ ഉണ്ട്, നമ്മളൊരു കാര്യം ചെയ്തുകൊണ്ടിരിക്കുകയാണ്. സോ ഇൻ ബിറ്റ്വീൻ someone is interrupts. So interrupt ചെയ്ത് കഴിഞ്ഞിട്ട് ആ interrupt ചെയ്ത കാര്യം എന്താണോ ആ കാര്യം റൺ ചെയ്യും. അത് കംപ്ലീറ്റ് ചെയ്ത് കഴിഞ്ഞാൽ മാത്രമാണ് പിന്നെ തിരിച്ചു അങ്ങോട്ട് വരുള്ളൂ. Come back to the main program. So usually for 8051 we have 6 interrupts. One is reset interrupt, then 2 timer interrupt, then 2 external hardware interrupt, then 1 serial communication interrupt. So these are the 6 interrupts in 8051. So reset, INT 0, timer 0, INT 1, timer 1, then serial communication interrupt. 6 interrupts. And these are the vector table for each interrupt. So whenever we get a reset interrupt, it will jump to the location 0000. When we get INT 0 interrupt, we will jump to 0003. When we get timer 0 interrupt, we will jump to 000B. When we get INT 1, it will jump to 0013. Timer 1 interrupt 001B. Serial communication interrupt 0023. These are the interrupt vector table. And all these are auto. This one is need an assistant from the program. RI and TA bit is using. That we will discuss in the next class when we are doing the serial communication programming. So this is the interrupt vector table, and all these locations are in the ROM. ROM memory lana we are storing all this vector table. And external interrupt pins are P3.2 and P3.3, INT 0, INT 1. So we can check in the pin diagram P3.2 and P3.3. So whenever there is a signal to P3.2, interrupt 0, external interrupt 0 will activate. Whenever we get P3.3 external interrupt signal, P3.3 will activate. Okay. This interrupt table check check doubt undo. 6 interrupts in 8051. All this interrupt is having a vector table, vectored interrupt, and these interrupt vector locations are there in ROM memory. 00004 for reset, 0003 for external interrupt 0, 00B for a timer 0 interrupt, 0013 for timer 1, external interrupt 1, then timer 1 001B, serial communication 0023. These are the interrupt vector table. മനസ്സിലായോ? Vectored interrupt means എന്തായിരുന്നു? Vectored interrupt means there is a specific locations for that interrupt where we can do the programming for that interrupt. So reset interrupt in location എന്തായിരുന്നു? Interrupt ROM location. What is the ROM location for reset interrupt? 0000. What is the ROM location for timer 1 interrupt? Timer 1 interrupt, what is the ROM location? 001B. Let me check it. Timer 1 001B. Very good. Very good. Now INT 0 location 003. Okay. That means 00002 0002 for reset interrupt. Reset interrupt in 3 locations are allocated. Then 00032 0000A for INT 0. So how many locations for INT 0? How many locations allotted for INT 0? How many locations were allotted for INT 0? Anyone? We have vector table. The first location 000 to 0002 for reset interrupt. Then 00032 000A for INT 0. So how many locations are there which is allotted in ROM memory for INT 0? Anyone? 8 locations. Correct. Anyone 8 location area? 0003, 04, 05, 06, 07, 08, 09, then 10, 1A. Sorry, 0A. 3, 4, 5, 6, 7, 8, 9, 8. 8 locations are 1, 2, 3, 4, 5, 6, 7, 8 locations. So these locations is the vector table interrupt service routine locations for interrupt INT 0. Above, whenever there is an interrupt request, the main program will jump to this location. In the program to the location. How many locations for timer 0 interrupt? Timer 0. How many locations? 000B to 000 12 0012. How many locations? 8 locations. Check it out. 000B, 0C, 0D, 0E, 0F, 10, 11, 12. What location? 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 locations. So whenever there is a timer 0 interrupt request, the CPU will stop the current execution in the main memory or main program, and it will jump to 000B, and we have a location available, 8 locations available for doing the programming for timer 0 interrupt. So I think now you got idea about vector table. രണ്ട് locations allotted 001, 00, 001, 002. 3 locations allotted for reset. 8 locations allotted for INT 0. 8 locations allotted for timer 0. 8 locations allotted for INT 1. Then 8 locations allotted for timer 1. Then 2, 3 to some particular location we can allot to serial communication interrupt. അപ്പോൾ ഇതിൽ നമുക്ക് എന്താ മനസ്സിലാവുന്നത്? ഇനി മുതൽ നമ്മൾ പ്രോഗ്രാം ചെയ്യുമ്പോഴത്തേക്കും we need to take into consideration that we have interrupt hardware in 8051. So whenever there is an interrupt request through that hardware to CPU, it will jump to these locations. ഇനി നമ്മൾ പ്രോഗ്രാം ചെയ്യുമ്പോൾ നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റില്ല? 0002 0023 locations യൂസ് ചെയ്യാൻ പാടില്ല, because this is using these locations are using for interrupts. മനസ്സിലായോ? എന്ന് വെച്ച് കഴിഞ്ഞാല് നമ്മൾ കീൽ സോഫ്റ്റ്വെയർ ആയിരുന്നു പ്രോഗ്രാമിന് യൂസ് ചെയ്യുന്നത്. നമ്മൾ ഇത്രയും ദിവസം പ്രോഗ്രാം ചെയ്തപ്പോൾ നമ്മുടെ ഫസ്റ്റ് ലൊക്കേഷൻ എന്തായിരുന്നു? ORG00H. But from today onwards, because we are doing interrupt programming, so there is a vector table for interrupt. So we already learned today what is interrupt and what are the vector table. From today onwards, നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റില്ല? നമ്മുടെ മെയിൻ പ്രോഗ്രാം 00H സ്റ്റാർട്ട് ചെയ്യാനായിട്ട് പറ്റില്ല. We need to use some other method. Okay. So usually we are doing like this ORG00H. Now we need to jump from this location to some other locations. അപ്പോൾ 8051 program ചെയ്യുമ്പോൾ main program usually start ചെയ്യുന്ന 30H എന്ന് പറയുന്ന location ആണ്. So ORG30H and main program will run here, because whenever there is an interrupt from the CPU there is a hardware, and hardware will jump the program from here to vector table, then it will run the ISR. So because of that, from today onwards we cannot do programming in 00H. 00H to 0023 is allotted for interrupts. ഈ ഒരു കോൺസെപ്റ്റ് മനസ്സിലായോ? So now, before starting this, I will ask some question. Okay. So how many SFRs we used for doing the timer programming? We did many programming for timer and counter. And for doing timer and counter programming, we used many special function registers. Which are all registers we used for doing those programs? Tell me the SFR related to timer programming. B register, DPH, DPL, IE, IP, P0, P1, P2, P3, PCON, PSW, SCON, SBUF, SP, TMOD, TCON, TL0, TH0, TL1, TH1. All these SFRs are familiar for us, and which all SFRs we are using for timer programming. Okay, one response from Aravind is TMOD. Okay, TMOD is one SFR. TL0, TL0, TH0. True. ഇനിയുണ്ടല്ലോ. നിങ്ങൾ പഠിക്കുന്നില്ല എന്നാണ് എൻ്റെ അർത്ഥം. TL1, TH1. ഓക്കെ, ഇനിയുണ്ട്. TCON, very good. So TCON, TL1, TH1, TL0, TH0, TMOD register. TMOD for setting the mode. TCON for overflow flags, TF, and then start and stop the timer. Then TH registers 0 and 1, TL register 0 and 1. So these are the different registers we are using for timer operation. Basically, TMO, TCON, TH and TL ആയിരുന്നു നമ്മൾ ടൈമർ പ്രോഗ്രാമിങ്ങിന് യൂസ് ചെയ്തത്. നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ നമ്മൾ എസ്കോൺ യൂസ് ചെയ്തിരുന്നു രജാത്ത ഷരീഫ്. എസ്കോൺ നമ്മൾ യൂസ് ചെയ്തിരുന്നു. Did we use എസ്കോൺ for timer programming ഇതുവരെ? എസ്കോൺ എന്ന് പറഞ്ഞ സ്പെല്ലിംഗ് മിസ്റ്റേക്ക് അല്ല, ടികോൺ. എസ്കോൺ രജിസ്റ്റർ ഉണ്ട്. ഓക്കെ, ഫൈൻ. Anyhow, these are the registers we used in the previous classes for doing the programming in timer. Now, for our interrupt activity operations, we are using SFR. One SFR is IE register, interrupt enabled register. It's very important. Interrupt enabled register. So here total 8-bit register. Out of 8-bit we are using 7 bits, and EX0, EX1, these two are the bit for controlling the external interrupts, and ET0, ET1 are the bits for controlling timer interrupt. ES is the bit for controlling serial communication interrupt. ET2 is the bit for controlling timer 2, which is not available in 8051, which is available only 8052. Then EA is the global enable, because if EA is equal to 0, we cannot enable this timer and external and serial communication interrupt. Only when EA is equal to 1, we can play with all these interrupts. So this is a global enable. If EA is equal to 0, no interrupt is acknowledged. If EA is equal to 1, each interrupt source is individually enabled or disabled by setting or clearing it, enabling it. This is for future purpose. We are not created any hardware for this one, this bit. ET2 is enabling or disabling timer 2 interrupt, but it is for only for 8052. ES is for serial communication interrupt, enabler or disabler. ET1 is a timer 1 enabling or disabling operation. EX1 for interrupt 1. ET0 for timer 0. EX0 for external interrupt 0. Very simple. If EA is equal to 1, we can play with all these interrupt. If EA is equal to 1 and EX0 equal to 1, we are enabling external interrupt 0. Okay? Clear ആണോ? ക്ലിയർ ആണെങ്കിൽ ഒന്ന് പറയൂ ക്ലിയർ ആണെന്ന്, അല്ലെങ്കിൽ ഒന്ന് ശ്രദ്ധിച്ചു നോക്കുക. നമ്മൾ പഠിച്ചിട്ടുള്ളതാണല്ല, ടൈമർ, സീരിയൽ കമ്മ്യൂണിക്കേഷൻ, എക്സ്റ്റേണൽ ഇന്ററപ്റ്റ്, ഇതിനെല്ലാത്തിനും there is a hardware inside 8051 microcontroller, and we can enable and disable that hardware using interrupt enable register, IE register. Clear ആണോ? Clear ആണോ? Okay. So this is clear. അങ്ങനെയാണെങ്കിൽ move IE comma hash 8181H. What is the operation? എന്താണ് ചെയ്യുന്നത്? Move IE comma hash 81H. What is the operation? Move IE comma hash 81H. What is the meaning of this instruction? Move IE comma hash 81H. What is the meaning of this instruction? എന്താണ് റെസ്പോൺസ് ഇല്ലാത്തത്? എന്താ ചെയ്യുന്നത്? ഇപ്പൊ ഐയുടെ വാല്യൂ എന്തായി? ഐ ഈസ് ഈക്വൽ ടു 10000001. ഇതാണ് ലോഡ് ചെയ്തിരിക്കുന്നത്. അപ്പൊ ഏതൊക്കെ ബിറ്റ് 1 എന്ന് നോക്കാം. മൂവ് ഐ ഈ കോമ ഹാഷ് 081H എന്ന് പറഞ്ഞാൽ 81H ഐയിലേക്ക് ലോഡായി. ലോഡായി കഴിഞ്ഞാൽ ഇവിടെ നമുക്കിപ്പോൾ ഉള്ളത് ഇതാണ് നമുക്ക് ഉള്ളത്. ഇതില് 1 0 0 0 0 0 0 1 അതാണ് 81H എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ. എന്താണ് 81H എന്ന് പറഞ്ഞാൽ വരിക? One 0 0 0 0 0 0 1. This is the value. അപ്പൊ എന്താ മീനിങ് അതിന്റെ? പ്ലീസ് ടെൽ സംതിങ്. ഏതൊക്കെ 1 ആക്കി ഇപ്പൊ നമ്മള്? ഇ എന്ത് ചെയ്തു? ഇ ഇപ്പൊ എന്താണ് വാല്യൂ വരുന്നത്? വാട്ട് ഇസ് ദ വാല്യൂ ഇൻ ഇ എ? ഇ is equal to 1. Okay. Now what is the value in EX0? EX0 യുടെ വാല്യൂ എന്താണ്? 1. So that means now our EA is equal to 1. EX0 is equal to 1. What is the meaning of this instruction? അപ്പോൾ ഇതാണ് ചെയ്തത്. മൂവ് IE, #81H. ഇത് ചെയ്തപ്പോൾ നമുക്ക് EA equal to 1 കിട്ടി. EX0 is equal to 1 കിട്ടി. അപ്പോൾ എന്താണ് നമ്മളിപ്പോൾ ചെയ്തത്? What is the purpose of this instruction? Interrupt enable ചെയ്തു. Which interrupt? External interrupt 0 enabled. Very good. INT0 is enabled with this instruction. Clear ayo? EX0 is for external interrupt 0. External interrupt എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ INT ഈ interrupt. External interrupt 0. INT0 നമ്മൾ enable ചെയ്തു. ഓക്കെ. അപ്പോൾ ഇത് enable ആയി കഴിഞ്ഞ് കഴിഞ്ഞാൽ നമുക്ക് ഇതിന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള പിന്ന് P3.2 ആണ്. അവിടെ സിഗ്നൽ വന്നു കഴിഞ്ഞാൽ മെയിൻ പ്രോഗ്രാമിൽ നിന്ന് 003യിലേക്ക് ജമ്പ് ചെയ്യും. ഇതാണ് അതിന്റെ മീനിങ്. മീനിങ് ഓഫ് ദിസ് ഇൻസ്ട്രക്ഷൻ എന്ന് പറഞ്ഞാൽ എന്താണ്? ഇനേബിൾഡ് എക്സ്റ്റേണൽ ഇന്ററപ്റ്റ് 0 which is INT0. ക്ലിയർ ആണോ? ക്ലിയർ ആണോ? ഓക്കെ. അങ്ങനെയാണെങ്കിൽ ഞാൻ വേറൊരു ഇൻസ്ട്രക്ഷൻ തരാം. മൂവ് IE, #82H. What is the meaning of this instruction? What is the meaning of this instruction? Move IE, #82H. Move IE, #82H. What is the meaning? ഏത് ഇന്ററപ്റ്റ് ആണ് എനേബിൾ ചെയ്തത്? എന്താണ് സംഭവിക്കുക? ഏത് വെക്ടർ ടേബിളിലേക്കാണ് ജമ്പ് ചെയ്യുക? enabled timer 0 interrupt. Very good. And which interrupt vector table now we will use? Which ISR? ഏത് ലൊക്കേഷൻസ് ആണ് നമുക്ക് യൂസ് ചെയ്യാൻ പറ്റുക ഇത് എനേബിൾ ചെയ്ത് കഴിഞ്ഞാൽ? You can use 000B2 0002. Sorry, 0012 അല്ലേ? 000B2 0012. These locations are now we can use. So meaning of this instruction is we enabled timer 0 which is T0. Enabled timer 0 interrupt. That means 000B2 0012. So this is the vector table for timer 000B. 00B to 0012 is for timer 0 interrupt. 13 മുതൽ timer interrupt 1. Clear? Clear ആണോ? Okay. Now, IE register concept is clear. Okay. Now, we will interrupt. So now we are discussing about this architecture part, interrupt control. We have external interrupt and also timer interrupt and serial communication. For most of the activity we have interrupt. And for pin diagram, we know that P3.2, P3.3. These two are for external hardware interrupt. So we can use these two pins for enabling interrupt. Then we discussed about the concept of main program and interrupt service routine. Then difference between interrupt and polling. Then steps of executing an interrupt. Then 6 interrupts in 8051. Its vector table. So total 0002 to 002 is the vector location for reset interrupt. And INT 0, 003 to 0012, 8 locations allotted for INT 0 in ROM location. 003 to 0013 to, sorry, 00B to 0012 for timer 0, 0013 to 001A for INT 1, 001B to 0022 for timer 1. From 2-3 onwards, serial communication we can use. So all these locations are in ROM location. Because of that, now today onwards, if you do programming for interrupt, we need to skip that interrupt vector table location, and we need to start main programming from in some other location. Okay, now we started with the concept of IE register. So just to go and read about IE register and how to enable and disable interrupt. What are the programs for enabling and disabling interrupts? Just read it well and understand it well. Next class we will continue about the other SFRs related to interrupt, and also we will do different programs.